Alright, so we're going to start with number 11 from the Chapter 1 test review on this sheet. Number 11 and number 12 both ask you to find the distance between the points that you're given. So remember, when you're asked to find distance between points, more often than not, you're going to use the distance formula. So I went ahead and wrote the distance formula above before the video started. So you know the distance formula is this formula up here, square root of x2 minus x1 squared plus quantity y2 minus y1 squared. Now remember, whenever you're given points, you should label your points as x1, y1 and the second point as x2, y2. So let's start off doing that. Well, they want to know the distance between points A and B. So I want to know what is the distance between points A and B. So the first thing I'm going to do is label my points. So I'm going to let this be x1, y1, and this is going to be x2, y2. So then we fill into the formula. So in the place of x2, I'm going to put 4. Formula says minus. In the place of x1, I'm going to put 2. And remember that this quantity must be squared. Formula says plus, parenthesis, and then y2, I'm going to put 9 minus, and the formula says y1, so I'm going to put 3, and remember I have to take the square of that. Now here, a lot of students run into mistakes simply because they square wrong, or they add or subtract wrong, or they try to put it all in the calculator instead of doing the work by hand. These problems are usually easier done by hand. Take them one step at a time. So order of operations says I have to do what's inside the parentheses first. So 4 minus 2 is 2. Don't forget that's got to be squared. Bring down the plus. And then I have another set of parentheses here. 9 minus 3 is 6. And don't forget that has to be squared. Now, order of operations says I have to square this. So 2 times 2 is 4. Bring down the plus. 6 times 6 is 36. And then I can add. So 4 plus 36 is 40. So the answer is the square root of 40. Okay, now if this would have been a real world problem, you probably would have put it in your calculator and got a decimal approximate. As we get further into geometry and I show you how to reduce radicals, or remind you how to reduce radicals, which is the square root, remember, you will simplify this. But for now, you can leave your answer as the square root of 40. So the distance between point A and point B, remember proper notation, is equal to the square root of 40. So that's the answer to number 11. So let's look at number 12. Remember, first step, you want to label your point, x1, y1, label the second point, x2, y2, and then fill into the formula. Now notice here, they want to know the distance between F and G. So in filling in to the formula, x2 is 1 minus x1 is negative 4. Now be careful. This minus here must go into the problem. This is negative. You cannot just say that the minus will take care of that negative. It doesn't. You must include both the minus and the negative. So then the formula says plus y2, which in this case is 8, minus y1, which is 6, quantity squared. So now following the order of operations, the first thing I'm going to do, 1 minus negative 4 is 5. Forget it squared. Plus 8 minus 6 is 2. Don't forget it squared. 5 squared is 25 plus 4, and 25 plus 4 is 29. So for now, you would write your answer as FG, the distance between F and G, is the square root of 29. Okay, so that is number 11 and number 12. So let's go on and let's go ahead and do number 13 and 14 as well. The first thing I'm going to do is write out the midpoint formula. Okay, so I've written in the midpoint formula. Remember, the midpoint literally means the point that is in the middle of a segment. So you have a segment that has the endpoints A and B for number 13. So essentially you have a segment like this that's on a coordinate plane somewhere, okay? And it will definitely not be horizontal looking at the points, but just so you can see what they mean by midpoint. So I want the point, this point right here, and that's a question mark, not a 7, that will fall in the middle of A and B if A is negative 1, 4 and B is 3, 6. So the first thing that I'm going to do is I want to plug in those points into the midpoint formula, which is this formula. Now notice I have x1s and x2s and y1s and y2s, just like before. So your first step is going to be to label your points, just like before, x1, y1, x2, y2, and then fill into the formula. So x1, the formula says x1, which is negative 1, plus, notice the x1 right here, plus x2, which is here, and they put that all over 2, because that's part of the formula, comma, and then they ask us for y1, notice y1 is 4, plus y2 here, which is 6, and remember the formula puts this over 2. You're wondering why, because you're looking for the midpoint. So the middle is half of something, so that's why you're going to divide by 2. And then you follow order of operations. So negative 1 plus 3 is 2 over 2. 4 plus 6 is 10 over 2. And then you simplify. Well, what is 2 over 2? That's 1. What's 10 over 2? 5. So the midpoint, let's call it M, of segment AB is going to be the point 1, 5. So that's your answer to number 13. And number 14, they want the midpoint of segment CD. So let's start off. We would have 2, because this is x1, y1, x2, y2. So x1 is 2 plus x2, which is negative 4. Notice I carried that negative with it, and we put that all over 2, comma, and then we say y1 plus y2, and then 2 plus negative 4 is negative 2, all over 2. Negative 3 plus negative 1 is negative 4, all over 2. So negative 2 over negative 2 is negative 1. And negative 2 over 2 is negative 1. And negative 4 over 2 is negative 2. So the midpoint, let's call it M, of segment CD is the point negative 1, negative 2. So those are the solutions to number 14, 13, 12, and 11.